Hello everyone, in this video we will learn how to write a coordinate proof. We have an example right here. Prove that a segment from the vertex angle of an isosceles triangle to the midpoint of the base is perpendicular to the base. So what we are going to do is first we will position and label that triangle over here, and then I'm going to make a list of given statements and I will write what I need to prove. Then we are going to start to write down the proof. So we have an isosceles triangle. Here's what I do when I have an isosceles triangle on the coordinate plane. Draw a random isosceles triangle, which means the legs are going to be congruent. Here is the base. Label the vertices A, B, and C. Now, let's say this point is point D. Now, the question is how many units we need to go to the right to get to point C from the origin or from point D. Now let's say we need to go a unit to the right from the origin to get to point C. That means the x-coordinate of that point is going to be A. Since we are not going up or down, the y-coordinate is going to be 0. Same thing applies for point B. But y-coordinate, since it lies on the x-axis, the y is 0. The x is about that number. So BD, the length of BD and DC are the same since this is an isosceles triangle. This y-axis cuts the triangle in half because the isosceles triangle, when we have a segment from the vertex to the base, it cuts the triangle in half. So BD is going to be A, which means from the origin to point D, we need to go A units to the left. Since we go to the left, the sign of the number is going to be negative. So now we have the coordinates of point B. The only problem is the coordinates of point A. Since it lies on the y-axis, the x-coordinate is going to be 0. That means we don't go to the left or right to get to point A. We don't know how many units we need to go up, so I'm going to use another variable for that. Now, since we have the triangle placed on the coordinate plane, now we can start writing the proof. But first, let's make sure that we have all the given statements here. So right now, I know that I have an isosceles triangle. It's labeled A, B, and C. And also, I know that point D is the midpoint of BC. What I need to prove is segment AD is perpendicular to segment BC. Because remember, that was what we needed to prove. So prove that a segment from the vertex angle, that segment is segment AD, to the midpoint of the base, which is point D, is perpendicular to the base. So what we need to prove is this angle right here is 90 degrees. That is the question right now. Let's get started then. Here is the proof. So right now, we know that point D is the midpoint of segment BC. So since point D is the midpoint of segment BC, the coordinates of the point, the coordinates of D are, right now, here's what we are going to do. Since D is the midpoint, it's going to be the sum of these two divided by 2 and also the sum of these two y coordinates divided by 2. So add the x coordinates, divide them by 2 since it's the midpoint, add the y coordinates and divide them by 2. This means that the coordinates of point D is going to be 0, 0. This leaves us segment AD. So segment AD lies on the y-axis. right now what we have is this segment right here, segment AD, lies on the y-axis. So we also know that segment BC lies on the x-axis, and therefore they are going to be perpendicular because the axes are perpendicular. The angle between the axes are 90 degrees. So let's continue writing it. Also, oops, sorry about that. Also, segment BC lies on the x-axis. Therefore, segment AD is perpendicular to segment BC, since the axes are perpendicular.